Okay, so we have a stochastic process z of t, that is n1 of t cos omega ct plus theta plus n2 t sin omega ct plus theta. Theta is uniformly distributed over from 0 to 2 pi, and n1 and n2 are White's stationary processes, and theta, n1 and n2, all of them are independent. So this is the information that's given. First of all, we need to find E of z of t. We know that E of z of t is E of n1t cos omega c t plus theta plus n2 p sin omega c t plus theta. And since these are all independent, we can write this as E of plus this one. Since we know that n1 and n2 are WSS, uh, the E of n1 and E of n2 are constants, so we can take them outside. So this is what we end up with, and since we know that theta is periodic over from 0 to 2 pi, we can write these two integrals. Now these two integrals will become 0 because these are periodic functions whose integrals become 0 over the time period. Thus we find out that the mean of E of zt is 0. And I also, what I meant to say was theta is uniform from 0 to 2 pi. So next is to find the autocorrelation, and which is nothing but E of z of t1 and into z of t2. So we write the values of z with respect to t1 and t2, which is this, and now we multiply the terms. Now since these are all independent, I can split the expected value individually, and I can group n1 of t1 and n1 of t2, E of that, as r n1 of tau, and similarly I can group E of n2 of t1 and n2 of t2 as r n2 of tau, and here n1 of t1 and n2 of t2 and all of those, I can write it as mu 1 and mu 2 because they are WSS and the mean is constant. So after simplification, we get this r of n of tau, r n2 of tau, and these.